Okay, so all we are doing is number 6, or is it 5? 5, okay, here we go.
5 ABCD.
Okay, so number 5, these are the graphs. Okay, so this should be easy. I give you polar graph paper, but you really don't need it, but I gave it. Okay, number 5A. Plus, I have the complete solutions. Did you guys even look at the complete solutions? Okay, now, 5A and 5B go together. Here's B. R equal 4 sine theta. Anytime you have a number times cosine theta or a number times sine theta, what are these graphs going to be? Omelet.
No.
It's a circle. Man. Okay, it's a circle, and what's the significance of the number?
It's the diameter.
It's the diameter. The cosine one is either here or here. The sine one is either up or down. Simple. So the first one is a cosine one. So if this number is positive, it's here. If this number is negative, it's here. So it's going to be here. Diameter 5. Look, 1, 2, 3, 4, 5, and then you just go. Woo-wee.
That's pretty.
Easy. And then this one. This is the sine one, and that number's positive, so it's going to be up here. Diameter 4. 1, 2, 3, 4. Whee! Circles.
How do you jump?
But you have to remember the form, though. That's the thing. Hey, man. Okay, next we got the limosomes. We should just make this thing small. We don't. What the heck happened? Where did it go? It just disappeared. Do I have to go back? Why did it do that? How do you get rid of this? Oh, I hate this thing. There. The limosome.
Croissant.
What? Did I? R equals 2 minus 2 cosine theta. Now, anytime you have R equals a number and then a plus or minus another number, cosine or sine theta, it's going to be a limosome. If the absolute value of this number is equal to that one, then what? Oh boy. The cardioid. The cardioid. The one that looks like a heart. A butt.
All done.
Okay, now, how do we graph these? How did we graph? It's like you guys don't even remember anything. You plot the quadrantal angles. Now, if you need to make this chart, then make this chart. So like 0, 90, 180, 270, 360. You really don't need 360, we'll put it there. So plug in 0, go. I guess I gotta call on people. Lee, that don't even look like a math book. The hole is just getting deeper. Lee, plug in 0. Just give the nervous laugh. Lee, plug in 0. 90 degrees, how do we know?
0.
No. Just read it off your paper. You have the whole weekend to do 7 graphs. You can do these 7 graphs in I could do all 7 graphs in like 30 seconds.
1.
No. What is cosine of 90 degrees?
0.
So what's 2 times 0?
Oh, sorry. 2.
Okay, 2. 180 degrees, Arita.
4.
270, Garcia.
2.
And then 360, of course, is the same as 0. So just plot these points. At 0 degrees, plot 0. So at 0 degrees, you don't go any units from the origin. You just right at the origin, or the pole. 90 degrees, you're going to go 2 units from the origin. See, that's why you really don't need the polar graph paper for these. At 180 degrees, you go 4 units in that direction. 270, you go 2 units in that direction. And then, of course, at 360, it goes back to 0. So it looks like this. So this is the butt, it's blowing to the east. The cosine one always blows either east or west, and the sine one's either blow north or south. But then, if you, like I told you before, you don't even have to know what it is before you start. If you just plot these four quadrantal angles, that'll tell you what the graph is. Okay, D. R equals, I can't even read that. 1 plus 3 sine theta. So what happens when the absolute value of that is smaller than that?
There's a tiny circle back.
Yeah, that's the hemorrhoid, right? Is that what you guys called it? Somebody called it the hemorrhoid. It's like a cardioid with a hemorrhoid. Okay, continuing on with the chart. 0 degrees, Galaccio.
1.
90 degrees, De Mello. Have your answers ready.
0.
Say what?
No, wait.
No. Cosine, what is sine of 90 degrees?
4.
Wait, 4. 180 degrees. Kim.
One.
Because you heard somebody whisper it.
No.
Arakawa, 270.
Negative 2.
-2. And 360 is the same as 0. Okay, now plot these points. You know why some of you are going to have trouble? Because over here, R is negative. You got to go the opposite direction now. That don't look like math, Lee. Well, you gotta quiz the next period.
Yeah.
Okay, at 0 degrees, you go 1 unit from the origin. 90 degrees, you go 4 units from the origin. 180, you go 1 unit from the origin. Now at 270 though, you gotta go 2 units in the opposite direction. So 270 is this way, you gotta go 2 units in the opposite direction. See how the placement of the point is in between the other 3? That's when you're gonna know you're gonna have the inner loop thing. And then at 360, it's 1 again. So remember, these 3 outer ones, that's like, it forms like a cardioid like this. And then you got the inner loop inside. So when your calculator actually graphs it, it starts here, it goes like this. No, it started here. Like that. But basically, you just gotta draw the graph. I think on the final exam, you just have to, I don't know if you even have to graph. I think you gotta graph a few, but some of them is just multiple choice. You just have to pick it out. It's very easy. Okay, and then the last limacon is 3 minus 2 sine theta. So what happens when the absolute value of this number is bigger than that one? You get the Manapua. So again, you plot the quadrantal angles. Have your answers ready to go. What's so funny? Okay, 0 degrees. Whose turn is it? Arakawa. Did you already go?
Yeah.
Chun. So whose turn? Did you already go?
Yeah.
Oh, Chun, 0.
1.
No. Sine of 0 is, look at the unit circle. Here's 0. What's the y coordinate of that point?
1.
The y coordinate. Here, look. This is the
Oh,
point.
0, 0, 0.
Okay, it's 0. Okay, so if that's 0, what's the whole thing?
3.
3. 90 degrees, Jung.
1.
180 degrees, Ignacio.
3.
Nua, 270.
5.
360, okay, there you go. So, at 0 degrees, you go 3 units from the origin. 90 degrees, you go 1 unit from the origin. 180 degrees, you go 3 units from the origin. 270, you go 5. 1, 2, 3, 4, 5. And then you're back to 3. So it looks like this. It kind of flattens out over there, and then you got a nice, healthy Manapua. Okay, and then the last 2 are going to be the rose curves. This is probably the toughest of them. So it's like you guys did nothing over the weekend.
Huh?
Yeah.
How do you know which side is the black side?
The one, okay, look. Well, you don't really have to know, like, if you just like connected like in a blob, then that's good enough. But, see how these two are symmetric, these 2 points? These two are symmetric about here, so then the one that's closest to the origin in between them, that's where it flattens off. But we don't really need to know that much. F, R equal 4 sine phi theta. Now this is the one where it's useful to use the graph paper. So let me, you know what, I'm not gonna do it, but you guys can use it. So first of all, how can you tell it's gonna be a Rose curve? When you have a number times either sine or cosine and you have n theta. How many petals are there gonna be? What? Who said 1? How many, this number tells you how many petals. How many petals are there gonna be? 5 petals. And what is the significance of that number? That's the length of each petal. Each petal is going to be 4 units long. And they're all going to be equally spaced apart. So what is 360 degrees divided by 5? 72. So every 72 degrees there's going to be another petal. But you have to figure out where the first one's going to be. How do you figure that out? You set this thing equal to what? Either 0 or 180. Which one is it? Now, what am I saying 180? It's 0 or 90? 90, because sine of 90 degrees is 1. That's the maximum value sine can be. Right? So 4 times 1 is 4. That's when you're going to be furthest from the origin, when sine theta is 0. What am I saying? 90. So you set this thing equal to 90. You solve for theta, you get 18 degrees. So at 18 degrees, that's where the tip of the first petal is going to be. So, see, you guys have the graph paper, but I don't, so then I have to do this. Hey, that's not bad. Okay, 18 degrees would be like, okay, so, like, you know on your graph paper, each one of those, I'm going to give you this now. Each one of these things is 15 degrees, so it's going to be a little bit past 15 degrees, right? That's for 18. So you look here, let me draw it in. So, what are we talking about? Like that. See, if each one is 15 degrees, that's 15, so a little bit more, that would be 18 degrees, right? Okay, now once you find the first one, just keep adding 72 to it. What's 18 plus 72? 90. So 90 will be the next one. Then add another 72. 162 can be right about there. And then add another 72. That would be 234. Didn't we have a problem like this on the homework? So here's 225 plus a little bit more, it will be about here. 234 degrees, and then add another 72.
306.
306. Okay, and then, I'm going to erase this. Okay, and then you guys know what the petals look like. Now, just remember, they don't overlap now. And they're not really thin either, so they should be kind of healthy. Like that. Actually, if you graph this on the calculator, it goes like this. It goes, woo, hoo, hoo, woo. Oh, no, that's not right. Start over again. Woo, hoo, hoo. Yeah. Yeah, that's it. That's the thing. Okay, and then G. R equals, what is this? 3 cosine 4 theta. 3 cosine 4 theta. Okay, this is the length of the petal. How many petals are there going to be? There's going to be 8. If that number is odd, that's how many petals you have. If that number is even, you have twice as many petals. So there's going to be 8. So what's 360 divided by 8? 45. So every 45 degrees, you're going to have a petal. But the key is you got to figure out where the first one's going to be. So for a cosine 1, you set this thing equal to 0 because cosine of 0 is 1. That's the maximum value of cosine. Therefore, that's as far as from the origin as you're going to be. So divide both sides by 4, theta equals 0. So the first petal is going to be at 0. Oh, I get it, Mr. Park. The cosine 1 always going to be at 0 then. Well, it is if I make that number positive. If I make this number negative, then what? What do you do? No, I wouldn't do that to you, would I? That would be like an honors question. Don't worry, it'll be positive. So if this number is positive, then the cosine 1 is always going to be at 0. Yes. Right? Because no matter what, if you set that thing equal to 0, you're always going to get theta equals 0, right? Just think about it. Okay, so 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay, so the first one's at 0, and every 45 degrees there's going to be another one. So then 45, 90, 135, 180, 225, 270. What is that? 315 and 360. So here's Johnny. Here's Johnny. Here's Johnny. See how they don't overlap? Here's Johnny. Here's Johnny. Here's Johnny. Here's Johnny. But that's not the way it's actually, because when you get to calculus, see, you guys are just drawing the graph, so you can do that. But when you get to calculus, it's not enough to know just what the graph looks like. You got to know how it's formed. So it's actually formed like this, you know. I'm trying to think how it is. Is it like this? Is it like that? I think it is. Yeah. You know why you need to know that? Because this is the kind of problems you do in calculus. Here's the graph. Find the perimeter and the area of it. What? But in order to do that, you got to know how it's being traced. You can't just know what the graph looks like. That's the kind of problems we do in calculus. And you guys know why, right? We have to find areas. Why is it important to find areas? Who takes physics here? Yamachita? Okay, look, if you have time, and you guys are going to take physics next year, if you are given the graph of velocity versus time like this, then what does this area represent?
Oh, acceleration. No, position. I don't know.
The distance traveled, the displacement of the particle. So if you are given the graph of the velocity, this area is the distance the particle traveled. That's why it's important to know how to find areas. You guys are taking physics next year. What are you going to do? Just wait till then, before you start learning. Now, okay, you know what? Since we're talking about calculus, I might as well tell you this thing. If this is the graph of position, what letter should I use? I'll just use X. If this is the graph of position, then what does the slope of the tangent line represent? Yamachita?
What?
If this is the graph of position, then the slope of this tangent line represents the velocity, the instantaneous velocity. Now, some of you, are you guys going to take AP Econ maybe even? Then it's important to know the slope of a graph because, do you guys even know economic terms like revenue and marginal revenue? Heard of marginal revenue? And you need to know the slope. So how do we? So that's why we study calculus, because calculus allows us to find the instantaneous slope at any point on the graph and how to compute the areas of any function. Because you know when you take physics, you know this kind of the only kind of graphs that you get are like this. It's all like straight line kind. So isn't it pretty darn easy to figure out the area? Because it's just like triangles, and then you can make rectangles and triangles. But in real life, it's not going to be nice like that, so that's why we have calculus to do that. All right, anyway. So tonight's homework is the rest of it now, 6 through 10. This is all the complex number stuff. Remember the arc is theta that we did? Well, hopefully you guys remember something. All right, we're done. So you guys have like 32 minutes. I got an idea. Why not do this and you don't have to worry about it? Oh yeah, Mr. Park, I wasn't going to worry about it anyway. So, you had a question?
Wait, so how come for that one you divide 5 theta, but it would be 5 theta because 90 is down?
Because sine of 90 degrees is equal to 1. Isn't that the biggest sine ever gets?
Yeah.
Yeah? So if sine of 90 degrees is 1, if this is equal to 1, then 1 times 4 is 4, right? So if r equals 4, that's the length of the pedal. So that means, so you're basically finding when you are 4 units from the origin. That means that's the tip of the pedal. Because see, the tip of the pedal is 4 units from the origin. That's why you do that. And then for cosine, you set it equal to 0 because cosine of 0 is 1. And then that's when you're gonna have the tip of the theta, when you're furthest from the
For
origin.
sine, we always set it to 90.
Yeah, so the
And
sine
then
one, you
cosine
set it equal to 90, and the cosine one, you set it equal to 0, which of course means theta is 0, yeah? Yep. All right. Now we only got 30 minutes. What do you guys want? What do you guys want to like?